Okay, so we've now done all of the pieces in order to port our sliding puzzle game to a WASM file to the internet for each dashboard. Last time, two streams ago, we got a texture rendering. Last time we figured out how to do something with the texture other than render it. That is just like animate it between grayscale and color as now. So we now have a way of getting textures to the GPU and rendering them. Previously we got a rainbow triangle rendering, so we had a solid colorways. So we can now kind of begin in earnest the attempt to port this sliding puzzle game. So so since then, like Zig 14 is well and truly released and updated. However, there are a number of breaking changes to build systems that the Zig 14 has introduced. I was playing with it a bit earlier today and yesterday, and it's going to take a while before the maintainers of some big packages such as Raylib and well, as well as the one we're using now, Zig JavaScript Bridge sort of update things, but they will get updated. It's just a matter of the people who are responsible for those projects doing that kind of stuff. So we'll continue using Zig 13 to build this example, to port it, and then when as soon as Zig JavaScript Bridge is updated, we'll port this, and likewise, once Raylib is updated, we'll then port previous projects that we've done. But for now, we'll just get this stuff going. Okay, so we can, we want to jump to our, I think we called it port, sliding puzzle game. So very long time ago, we created the rainbow triangle example, and this was the thing that imported ZJlib, but otherwise everything here can kind of go. So let's port. What's an Zig out just again? So yeah, let's just begin to call everything here sliding puzzle instead of rainbow triangle. So we'll be making a sliding puzzle WASM. The path here will be able to pull out the main, I think. We can keep it like this for the moment. Build the sliding puzzle static website, and then okay, so we'll replace this rainbow triangle. Yeah, for the main here, all of this is going to change. For the static, there's a couple of changes we need to make. Okay, so here we want this to be sliding puzzle in Zig and WASM. I guess whatever the canvas is initially, who cares, since we're going to modify it anyway. This is the sliding puzzle, and that should kind of be it. Okay, let's move sliding rainbow triangle to sliding puzzle, and then let's try building this. So we can do, let's just clear out whatever's in the zig cache, clear out whatever's in zig out, and well, since my system is being updated to have zig 14 now, what we really want is zig 13. Zig 13 build. So this should just produce the rainbow triangle example as before, but with a different name. I'll keep this one around. Oh, something failed. No build step name run. Huh? Wait, what? Normally, if the build system fails, it produces a better error. Let's try and do. Oh, right. I guess I wanted zig build sliding puzzle. We'll adjust this later. So that zig build run just actually does the same thing. Meanwhile, here we want sliding puzzle, zig out bin. Oh no, zig port, zig out bin, and then here, yeah, we want to launch Python HTTP server. Okay, we're gonna have to delete the cache. Okay, there it is as before. So now that the build system is taken care of, we can proceed to support the program. So, how do we want to go about this? I feel like I want to, we'll copy all of the code over. I think we can disable most of it. We'll get the fragment shaders and vertex shaders for the background working first. That itself it shouldn't take too long since we've established everything. Once that's working, we should then be able to port over the color texture shader. That will probably be a bit more effort, but get that working, and then the screen should look correct. And then we can move on with the game logic. Okay, so yeah, I think we just want to completely clear everything that's here and jump. So yeah, let's jump to our cleaned up rainbow triangle example. Or rather, actually, what's the most complicated one we did was the texture. So we'll use that as like the base or something to compare it to. And then we'll start copying everything over. So we've got our dwarf planet base code here. And then let's go over to the source code of our sliding puzzle, which is, yeah, less than 900 lines, basically all self-contained. Well, I mean, it does, we are using like a minimal like wrapper for GFLW and a minimal wrapper for OpenGL, but otherwise the same. Okay, now it's copied in there. So we jump down to main. I kind of want it to be looking at the side of the screen. So what are we going to have to change? So the stopwatch, these things are going to have to change. Presumably these things are going to have to change. I suspect these are not implemented for WASM, but maybe they actually are. No, surely not. Anyway, we can check. What should, let's just say like update. Okay, init the grid, that's fine. That this shouldn't require having to put anything. Oh, yeah, it shouldn't do anything. We wrote our own version of this X of the random stuff. These own shuffles that are in there will be fine in the WASM. So yeah, init grid should be good. Decompress QRI images. This as well we'll have to update. But only insofar as having to do like the trick of like unpacking the like vector of the array of vectors. Each vector is a color to like just the array of bytes, because of uncertainty as to how like the WASM's laying out the bytes in the memory. So this stuff we'll have to deal with. And yeah, the names for these as well should be adjusted. I think Blue Marble Pixels is a better name. Quote Pixels is a better name. And then update, convert these to arrays of well, to U8. Then okay, and then we have a bunch of GFLW stuff that is certainly going to go. Yeah, we can just get rid of that entirely. And init OpenGL, clearly this will go as well. Let's just comment this part out and then figure out what the corresponding thing to do is. So the corresponding thing is initting the WebGL context, and this is very straightforward. So I am slightly surprised that when like initting this WebGL context, we didn't need to pass a bunch of pass any kind of hints, but I guess I guess we have to pass the hint since we were doing it through a window manager, and since it's in a browser, this gets handled for us anyway. So we'll just copy this over immediately. Init we want this to be init WebGL context instead. And then where we had that, we want to have init WebGL context. Okay, compile shaders is gonna have to change, but hopefully we can just copy. I guess in the cases we've done so far, we've only had a single shader, so we didn't have to compile multiple versions like this. We can probably I was gonna say turn what's over here into a single function, but there's like specific locations we have to link, and it's not immediately obvious to me how to do that in some other function like this. So yeah, for the moment we'll keep it as like compile single shader until we get the background working. It would be good. Well, I guess it would be good to have a catch unreachable, and then just copy in what we otherwise have. And I don't think anything in here is going to really change. Okay, then setting up the array buffers, this is totally changing. So let's see. So in the very first case, when we're doing the fractal kind of thing, I don't think we even need this. If it's just a background fractal, let's see, when we check out looping fractal, what was the code we wrote for this again? Setup array buffers, yeah. Let's just copy in this stuff. Yeah, there's a lot of extra stuff here to do. A lot. Okay, and then process input. I think the process input and the updating of the state and the computing of the grid geometry, we can all just put to the back for the moment. And then for the rendering, what here? Yeah, like basic, a lot of this is going to change. how should we import this stuff? Do I even have a render loop? I guess for us the render loop is this animation frame. So we'll copy this over. And then the actual part, which is, if someone passed it, render, we can get rid of this window destroy, we're not using that. Animation frame. What we need to call is this instead. We don't need the polar events, we're going to have to say port. Okay, finally what else? We're gonna have to copy over the shaders. So, where are we? Okay. So this is our port. We'll make a directory for the shaders. So at this stage, let's just use file pilot. So at this stage, we just want to try getting the background shaders ported. This and then this. So we can comment out those ones. Okay, for all of, let's just comment out all of the QOI stuff for the moment. Already just what else? Compile shader we're gonna have to adjust. Since this is really going to depend on the actual shaders itself. So what are we going to have to link here? Well, what did we have to do in the fractal example? So the vertex shader for this was really simple, as it will be for this one. So yeah, we just wanted to pass in the APOS, and okay, I see we are normalizing it here. So we'll need to, well, we already copied in the data structure that worked for the fractal, so that should be okay. was kind of wondering why this stuff was inverted. I guess since it was a copy pasta, but otherwise it should be fine. Okay, unless okay, that's why we normalized it, since we had stuff here, but we're basically replacing most of this anyway. So yeah, if we're replacing it anyway, we can do what we want with it. Calling this vertex shader is not the best. Not the best name. Okay. So we're also going to need to adjust the fragment shader background. So this is what it is for the fractal, and then for the what do we have it as in the original? In the original project, this was fragment background. Oh wait, this was it. Oh, it's just assuming since it was fairly large. Yeah, there's gonna there may be a lot to convert here. Maybe I can start using the buffer. So yeah, this thing we need to port. Let's just make this clear. Okay, so the specific stuff we need to port is all of these numbers. We specify the precision of the float, have the time as uniform. Okay, what have we got in our version? Out frag color. That I guess can be changed back to GL frag color. Then yeah, we have float pi, that's fine. Uniform float LP and uniform float radius. Okay. Time is gone and we just have those instead. Constant ints and floats. We're getting frag code, we'll see if that is okay. Oh, the fact that this isn't okay, we'll try and we'll give this one a go. Okay, in either case, we need to do uniforms for both the float and the radius. Actually, it's kind of driving me totally nuts that we're putting this inside like a file. There's like too many sliding puzzle directories going everywhere. Yeah, we jump back to the uniform stuff. So we need to set uniforms for both the float and the radius. And how did we do this? Let's just set it for something like super temporary at the moment, and then we will update it. We'll get it properly. We'll set it, we'll port it later. So you want LP uniform location and radius uniform location. LP radius, and then we want to set these. Time seconds F32. So yeah, geo context. And now let's just set. We may as well do it now. So let's see, the values we use are just a set in this code. Oh, there's like the entire issue of timestamps instead. We'll see if the stopwatch works for the WASM targets. If not, we'll have to do this. So this is assuming WASMs implement a timer. We can do this. Otherwise, we'll simply say const program seconds is equal to time seconds F32. Okay, then then we've got these uniform renders, then we can set them. So now we can say LP uniform and radius uniform location. Set these to be the LP value and the radius value. Okay, and then probably still is that for that. Oh, anything that's like GL dot is going to massively confuse the compiler. So I guess we should get all of that out of the way. Likewise, those libraries will confuse the compiler. We're gonna have to replace a lot of this. So If we go to main from the capital sliding, no. What do we want? We want the we want the looping fractal main. So we want to import this, basically all of this stuff instead. All of those type aliases can go. We want to keep those ones. Keep these colors and constants. Tile width, centers. I guess these errors have changed. Yeah, I guess we're not using these anymore. No GFL window pointer anymore handle. We'll see about those. Keyboard's fine for now, it's not doing anything. Alright. Oh, this is going to be such a rough one. Yeah, I knew it. Even just to render the background on the web is going to be a significant amount of effort. Like it's, but it's all like cleanup and putting stuff together. Like it's not, we don't really have to write any like original code for this part. It's just copying and modifying stuff. Okay. So now we want to do zig build sliding puzzle. Zig 13 build sliding. So, okay, great. Use of undeclared identifier VAO 159. I think it would be useful to keep these here and replace them with handles. Provided we keep in mind that all of this stuff is handles. Okay, so I guess we actually want to go back to the main and the actual sliding puzzle. Okay, include all of this stuff again, even though we just deleted it. What's that too? But now replace all instances of the cuint with JavaScript bridge dot handle. 268. Undeclared identifier, compile shader, 279. Undeclared identifier window. Yeah, that we don't need anymore. Do we even need to get Oh, we're gonna have to move the frame timestamp inside of the animation frame. So much stuff is changing. Like this is, we're gonna have to move all of this inside like the loop. In either case, let's just get the thing on the screen and then we'll figure stuff out. 299. Undeclared identifier QOI. Yeah, let's just comment those out. Texture shader program, undeclared identifier. But this we do need to change. Four, 6, 8. So this we want to replace with like background shader program. It's just called background shader. We really should change this to background shader program. Texture shader program. Okay. All instances of texture shader program replace with background shader. Shader program. More. Oh yeah, I guess all of these need to go. Okay, we have hit this WASM issue. At least currently, but probably even with the rewrite. Okay, so how are we gonna deal with this? I really don't like just like getting passed in like seconds instead of just like this is like the timestamp from a monotonic timer. I wonder if there is some way of calling a JavaScript function to do this. Can we say like get POSIX time? Date.now returns a Unix timestamp in milliseconds. How do we do it in the rainbow triangle example? File no longer exists. How do we do it in the fractal? Okay, so we have this like init clock. Do we have that here? No, we haven't yet copied this over. So we've said like timeline and then like get current time. Like I wouldn't even know how to like from within the WASM do this. It's new. What even is this date object? I don't want to like go back to the JavaScript, world of JavaScript hell, so we might just let alone like I'd like at no state like there's no there's no allocators being called in this program. We want to keep it this way. We don't want to like have to make some like allocator just to like store like a single date object just so we can call like .now and we already have a time system that's already working. We'll just have to port this with this. Okay, so where are the timer examples? Let's just like uncomment this stuff for now. Yeah, let's just get rid of all like timer related stuff now. Until we've like got the background rendering on the screen, I don't want to have to think about it. Yeah. So again, like, do we have if stopwatch is commented, then we don't. Then it won't be a concern. Okay, great, that compiled. Whether it's going to run, completely different question. Port Zigbin, the stuff is there. So now I want to do Python and HTTP, so and we'll get this, figure this out. Okay. Something may not have functioned. Oh no. Okay, I think this is because this is different than what it was in. Yeah, it's not pub main, it's like export. function main. Okay. Okay, vertex shader compiled and stuff did link. Weirdly, we're not getting like fragment shader successfully compiled. That's something feels really off. Why isn't that printing? Oh, we just didn't print the message. What? Okay. That's weird. I could have sworn we did. Anyway. Okay, great. All of those compiled successfully. Okay, and now nothing's on the screen because we're getting. Because why? WebGL rendering context, argument 1, not an object. Like if we just step back of like the ways of porting this, a simple way would literally just be to like recreate the entire program by just copying snippets of code bit by bit from like the fragment shader with the fractal example, just because like everything is so brittle and yeah, everything is so brittle. So I was like, no, we'll just go ahead and change everything, and now I'm paying the price. Yeah, where even begin? Okay, for this LP value, we were setting this to be like time seconds, and I guess if this is undefined, then oh no, we're setting this to be the timestamp. We did set that to be 0. Argument 1 is not an object. Well, honestly, copying stuff over, it was like so complicated to begin with. I'm just tempted to, like, even though this is less than 1,000 lines, it's like, it's somehow too unmanageable. I'm tempted just to delete everything. We'll just copy the fractal example over, literally like modifying only that, get the background shader working, slowly start adding other stuff into it. I don't know how like from this alone you're meant to like figure out what's happening. Oh, okay. Actually, okay. Apparently you can figure it out just by clicking it. Okay. So the get uniform locations are failing. That makes more sense. So, these are these uniforms are called LP and radius, and why is it whinging? Argument 1 is not an object. Why can't we just pass these floats? That's what we're doing, is it not? Oh, maybe this LP value, we didn't specifically say this was an F32. Is that why? Just load it. No, argument 1 is not an object. What? How did we assign these in the fractal case? Yeah, this I with every minute that passes, I'm like, we just need to clear everything out and just start again with this. No, we just passed in. We passed that in just fine right there. Yeah, it's there's let's just clear everything out. It's just destroy everything. Cancel. No. Yeah, porting it in this crude way has failed. We're just going to build it from the ground up again. Too complicated otherwise. Okay, so okay, hopefully we haven't actually touched anything in the original shader initial sliding puzzle. Apparently we did. No, just reset that. Reset everything. Okay. So back to the port. Yeah, so here, yeah, okay, we're going to have to delete a lot of stuff. So let's just entirely get rid of the sliding puzzle that's there. So instead, we want to let's get rid of everything. We just want the dependency, the shaders, and then the files from the fractal, nothing else. And then we'll just try and get that working. So, okay, in the WASM examples, fractal example we did, whatever's in there, delete. Move those to here. And then we just want main. But here, instead of main, we want to call this sliding puzzle. Or port, sliding, port, sliding puzzle. And while we're at it, okay. All it is. So why are there all of these like crappy temporary files anymore? Okay. Okay, back to the build file. So the root source is now just sliding puzzle port, or rather port sliding puzzle .zig. Okay, there's a whole bunch of static stuff we'll have to copy. That will now just be within static. And keep it like that. So copy the static into the port. Hello into the port. So annoying. There it is. Okay. Zig build, zig 13, build sliding puzzle. Okay, unable to open vertex shader. That's good, because we would expect that to happen. Since we moved it into shaders, the vertex shader, okay, but otherwise that built. So now let's I'm waiting so hard for Ghosty to come to Windows. PowerShell is just dog shit. It is so bad. And I've looked at other alternatives and they're basically just as bad. Ghosty though is like, we'll replace it in the same way that file pilot is replacing everything. Ghosty will replace everything. So I'm gonna do port shaders. Zig out bin Python HTTP. So yeah, so literally the only thing this should have is the fractal. Do I have to delete the cache again? Yes. What now? Oh, I think we need to rename like the WASM. We need to rename the static. Everything is called port sliding puzzle. Yeah, let's just put it that way. Okay, hurrah, it's working. Let's just save this. Yeah, a lot of stuff will have changed. So here we want to say white project with ported WebGL fractal. get this on GitHub. Alright, so now we'll just begin the very simple step of replacing this with the background shader. I should have done this method in the beginning. I was way too gung-ho. Okay, so yeah, so we want to replace the shaders in here with the ones from the sliding puzzle game. Also, I have no idea how people who like port games for a living wake up in the morning. Like, this is so painful. Like, who would want to do this as a living? This is like, I'm gonna make the game for like a sensible platform and then not have to touch it again. So yeah, get rid of those, and then the vertex background and the wow. Can I do Control Z? Oh no, pilot rules with an iron fist. We need to know like the crappy syntax changes to make, but we'll get to that. Actually, the compiler we'll get it. We'll get to it eventually. So okay, now we open this and we need to replace these names. So what are the names of these files in the shaders? These are fragment background and vertex background. Vertex background. Okay. So this should still compile. It's just not going to run because compile shader errors. So let's fix these up. Okay, so shaders. So yeah, basically all of this. I think all of this can be replaced with whatever's in the fractal. So if we go to the Zig, WASM, WebGL, looping fractal, vertex shader, we'll just plonk that in. Okay, now the fragment shader needs to change. So in the looping fragment shader, we have to copy in this kind of crap. So this stuff. So yeah, the frag color, right, we're replacing with, like we already did this earlier, I think I remember. It's like GL frag color, right? And then these things that are currently uniforms we will replace. Replace these with uniforms. For now, we'll just make them constants. And we'll make them, LP is 2, and then the radius is whatever this number here is. Good thing we added it in as a comment. Okay, and then there'll probably be some like shader compile errors, but for the moment we can move on. Okay. Our favorite kind of errors. Cannot convert const into const float. Why does this look familiar? Okay. So 2.0. Line 14, invalid number. Okay. That is a legit error. Still failing. 39. Wrong operand type. No operation exists that takes me_dump2 component vector float to a right operand of const int. 39. I knew that was going to be, this was going to happen. Okay. So if we make that a 0 instead, any other issues? Line 40. Oh, I guess multiplying by 2 is not acceptable either. It's meant to be 2. Okay, likewise, probably the one. Well, we'll see if this line. We'll see if line 52 gets flagged. Yep, as predicted. Final color. Okay. Are you happy now, compiler? I added 0.0 to everything. Okay. Hurrah. The background is basically compiling. Time to take a break. Just kidding. Okay. So yeah, lots of stuff has changed. So I can say, what exactly has changed? Yeah, that looks fine. Oh hey, hello again. Did I consider Circle as cross-platform? Yeah, like Circle is probably is something I really want to look at. I think Circle is really. I think there's a lot of good reasons for it. Like one of my friends uses it for their own like single person company. Been using it for years. I think like the bindings that Circle uses for Zig are like maintained by the authors. Like it's really good. I think I still want to just try and like I've already learnt a lot by trying to port this myself without using like Circle or something external. I just want to kind of try and push through this for the moment, and look, maybe down the stream I will also port this with Circle, and then I can just see the differences. Like it would be, I think it would be good to be able to just compare performance-wise, compare binaries-wise, and also just like compare the development process as well. Like I guess to get to this point, it's taken me what, like almost like a week of like porting like the small examples to get to this, knowing that it just takes a week to do this kind of like translation is itself useful. But then, yeah, if it only takes like 3 hours to actually put stuff with Circle, then that's also really good to know. And, something I might use for the future. But yeah, for now, we'll just I'll continue with this. And also as well, like I guess this is a project with hardly any large dependencies. Like the Zig JavaScript bridge library is really small, and so it's something that my prediction is that like it would be easier to maintain something like this than with Circle, but I also don't see Circle disappearing anytime soon, so maybe it's like a moot point. Okay, got a background constant, background shader, rendering. Okay, so now that's part is done. We can convert the constants here to the uniforms that they should be. So let's see. So this is still just the pure fractal example. I guess I'm calling it rainbow triangle instead of the fractal. This doesn't feel right. No, it is fractal shading program. Okay, so uniform float. We'll just start with the LP value. So here we want to do set. Why is the indenting all off? Set the LP uniform in the fragment shader. So here we want to do. Here we'll need to port it. So we need to check out the code we had for the original sliding puzzle. Okay. So we got the program seconds, which is just the seconds since the program spun up. So that is basically the cost of that time seconds. Use that to get this value. The radius is dependent on some variables. Let's comment that out for now. We'll add those in very soon, and then we'll address it next. And then here we want to replace the time with the L. It's just LP, right? .gl fragment background. Yep. So here we can have LP uniform location, LP uniform location, and LP value. Okay, let's try compiling that. Okay, undeclared identifier pi. that is easy enough to fix. Pi is standard.math.pi. Or rather, maybe we should make this like an F32. Undeclared identifier program seconds. I thought we adjusted that. Oh, program sex there. Background shader shape change time. Okay, this is another port we'll need to do. What's happening now? Okay, and it built it. Great. Okay. Uniform cannot initialize this type of qualifier. Okay. Fragment background. Okay. Okay. But otherwise this is running, and kind of by design it's meant to change really slowly, and so we wouldn't really be noticing it. But that means it's hard to check if it's actually working. I feel like since it's compiling, there's no reason to doubt it's not. I suppose the easier way would be changing this from, say, like 200 to 1. Yeah, okay, it's working away. Good. We just want this to be 200 instead. Okay. So now we want to update the radius value. But this requires adding in these variables is1 and animation1 fraction. So where should we do that? You can add that in. Is it in main? Did I not open it? Really? Really? Okay, so we need to get animation1 fraction. We may as well just copy over this entire thing. For the moment, we'll have to uncomment grid movement direction before we add that in. And we'll have to have some like temps as well. All of these are constants that can move up here anyway. We should probably set animation 1 fraction temporarily until we get the logic working. What's the best way of writing this? Maybe this. So animation 1 fraction is equal to, it would be 0 at the beginning. But we also need a copy is 1. Is 1. So we have that in the game. Logic globals. WebGL. Unused local constant, radius value, 239. Well, that's because we haven't yet changed it in the fragment shader to a uniform. So let's see. There's like too many fragment shader stuff that we're getting rid of. I can say uniform float radius is equal to this thing. Then we need to get the location. Radius. Well, just replace LP with radius. Then update that with the radius value. Okay. I can try building that, running it, and great. It's now like more what we were going for size-wise. Okay, but actually, is this what we were going for? See out sliding. Yeah, there's something. I noticed this with the triangle example. There was something like slightly blurry with the screen. I think it's because, oh, this is zoomed in at 140. Okay, now it's all right. That's matching the size. It's kind of working. Okay, fragment shader ported. One down, many others to go. Yeah, we didn't modify both of those. So now we want to say ported background shader. Now I think this background shader is called like the fractal shader program, so that as well is something to adjust. Fractal shader program. So what did we call it in the sliding puzzle example? I think it was just background shader. Okay. So replace fragment shader with background shader. Oh, do we want to change this stuff as well? I think so. So, okay, we just called this vertex background and fragment background. That was wrong. Similarly, we want to do fragment shader with fragment background. Okay. Yeah, this is the thing we mocked up, 139. So this should just be vertex shader. But it's good that we actually get a compile error. Yeah. Okay. Oh, we were doing this in like totally wrong part. Okay. That's all right. Okay, so those names have been changed. Okay, so now it's like, so now what to do? We may as well say these. Name changes. Okay, we could either try getting the other shader rendering. That's going to be a lot more work, like significantly a lot more work. Or we can try getting the rest of like the game logic in. In a similar way that when we started afresh, we just like imported the fractal example, verified that worked, then modified it to what we have. I think it would be wise to completely copy and paste in the Pluto example, get that working, and then just begin modifying it. And then once that's rendering, then I think we'll be in a better position to update all of the tile stuff. I almost want to leave like the game logic to the end. So it might be wise to like get that in at this point already. Not that there's much we could use it to show anything though. It's not interact. We can't interact with it either anyway. So until we start like porting all of that. Yeah, I feel like a better aim is just to yeah, like port the game to such an extent that the only thing that's missing is the input. And if we're going that route, we can forego the game logic before at this stage before we get like the texture rendering. And once the texture's rendering, then we can go forth with that. Yeah. Okay, so now we have to be really careful as to what we add and how we do it. We've also got this other complication that we're now having multiple shaders, which itself could be fine for the moment. Yeah, let's try not to merge any of the current like functions together. We'll just keep everything separate, and then this way we can just like comment out everything we just added in until we get the Pluto that accepts, with the blue marble working, and then we can like activate both, and then we've got both shaders going. So let's change the names of these functions to reflect that. So compile shaders, we now want to have this is like compile background. It's also compile and link. Compile and link background shader. Compile link. Let's compile, that's fine. Compile background shader, and then when we set up array buffers, we can say set up background array buffers. It's more like array buffer. It's just a single thing. Then yeah, still working. Okay, so now I want to comment out, compile the background shader and the background array buffer. And we're going to add in the Pluto example. However, we'll need to adjust the uniforms that we're calling in here. We do need this term for this part. This is still called fractal shader program. I thought we got rid of that. Fill shader. It's now background shader. So yeah, so what's changing? So render the background. This and this, all of the uniform setting, as well as the drawing command is going on pause. So now when we render this, we should just get something that's just like a boring background, but no errors. Yeah. Okay. Git status u, git diff, deactivated background shader. Unknown switch m, what? Oh. Git commit. Yeah. Like I'd say, like another thing, another skill that is, I think, I'm finding is really difficult to develop is just managing this code, this level of code complexity when you're like having to modify like almost all parts of the program at once, and everything you're doing is like low level in some sense. Like I think stuff like Circle can handle a lot of these problems by a lot of work's gone on behind the scenes to present you an API that's that I'm sure like in all APIs, like if you move things in like the wrong order, that kind of stuff, things will break. But it's at least it's more it's less prone to kind of break for like with this like I'm finding like there's something to be learnt about just like having to just I don't know, just having to work with like this style of code, I'd say. If it's like if you're like working with Raylib, like there's almost nothing you can do to kind of break it. Everything kind of works, is very straightforward. But that's because like behind the scenes, Raylib is doing all of this, but doing it in a like in a like sophisticated and structurally sound way. But when Raymond was like developing that, like he had to develop the skills in order to do that. And I'm finding working on this is like a great way of like I don't know, I feel like this is how I'm learning how to like do all of that like careful stuff where like where it's like it's hard, but I it's hard and it's not fun, but it's like I can feel skills being built, and it's like I'm happy to do it like I'm happy like this side of the line. Okay, so now we need to port the let's just clear out okay, get rid of clear Emacs, git clean x and get rid of all of that. Okay, so yeah, so now it's the next hard part of porting the Pluto texture. So in our WASM examples, here we had very vaguely named vertex shader and fragment shader. Then there's also the assets of the New Horizons QI we'll need to add. All right. What else? We're gonna have to change the name of these generalized shaders to what we called them in the actual sliding puzzle, which is what vertex color texture and fragment color texture. So vertex color texture and fragment color texture and we need to import those. We can just copy these. Shader source files. Oh, we know what those are. Okay, but here we're going, since these are the Pluto examples currently, we want to we're going to have to just copy in the Pluto code, and there's going to be a lot more things to copy in than just these. So in our Zig WebGL examples, for the dwarf planet, under static draw, so many more. I think we can get rid of these since we're just adding to them. And paste them with, we should paste these with the note. Paste them with that. We still should be able to compile this. Zig build sliding Where's the Ziegler sliding puzzle? Yeah. It should still run as well. Yeah. However, now we need to do all of the QI stuff. Where to do this? Let's do this above main. Oh, but here we're gonna have to. Right. We're just directly copying the Pluto example to begin with, and then we're gonna put it. So, so here we have assets, Pluto New Horizons. There's all of the comp time stuff. Then this stuff. Okay, and then on to the actual well, almost everything. So we'll just call this stuff so it's yeah, it's clear in the future exactly what this is doing. So init, we don't need to, ooh, maybe we will need a different init web. Surely nothing's changing in the init WebGL context. No, this stuff's the same. That stuff we don't need another version of that. But for the compile shader, when I have compile a Pluto shader and then set up Pluto array buffer, and then yeah, there will be stuff. Yeah. So what did we do in the decompress image? All of this. And then in the compile shader, yeah, this is where stuff got. There's a lot of repeats, but a lot of custom stuff too. So it's this compile Pluto shader, and then this is the stuff that when we link it has APOS and tech coord, yep. Okay, then setting up the array buffers. Very involved. Set up Pluto array buffer. Okay, and then finally we've got the animation frame, and what's happening in this. So in this case, we are setting a bunch of uniforms. We can kind of ignore those uniforms since we don't, yeah, since from memory, there is no uniform in these parts of the shaders. Everything, we're just passing in all of the data and the GPU is dealing with everything. We can check though, fragment color texture. Alright, aside from like the texture, oh, the texture is a uniform since since we changed it a couple times. Yeah, we draw some. Yeah, we draw some triangles with the earth texture, and then we swap it to the quote texture, and then draw more stuff. In either case, what? In either case, we can just copy over what we have here. So if we've already got this time seconds in here, there's probably going to be some uniforms around the place that need to be updated as well. Like I'm not imagining this texture shader program is anywhere, no. So let's update that. Let's call it like Pluto shader program. And then, what was it, texture shader program. We're replacing with Pluto shader program. Okay. Let's build, or try building it. The spam always happens on stream. We'll ignore the, oh, maybe on my iPad I can do it. So right, we need to do the QRI imports. Well, so okay, so in our port of the sliding puzzle, until like the new build system comes in, we can just call we may as well have it going. Depths, just dependencies. Dependencies, copy in qi.z. And then we want to have constant qi equals import dependencies qi.z. The undeclared identifier color, undeclared identifier decompress Pluto, vertex shader source. Okay, a couple of things happen. Yeah, so for the dwarf planet case, where do we put type aliases? Probably like above the WebGL constants. What are some other errors? Decompress Pluto. So this was just that. Then vertex shader source. Vertex shader source. Wait, what line? 254. Right, this, yeah, we need to update the names of these. So, so we called these vertex colored texture, but really they should be called vertex colored texture source. We want to replace vertex shader source with vertex color texture source. And then similarly, fragment shader source with fragment color texture source. Okay, and then those get converted into, well, the strings of those get passed to the GPU. Pluto shader program unidentified. But we identified it here. Oh, program, not program. Undeclared identifier texture. Oh, maybe this we need to add in as a variable. Yeah, not here. Where are the other variables? What did I add with that? Yeah. Pointless discard of local constant. But we need to use it at some stage. used here. Oh, it actually is used later on. Okay, that compiled. Is it gonna run and show the image of Pluto though? Huh, and it does. Oh, and it's actually, what? Why is it? Okay, I guess we didn't purposely like disable the stuff that would change it. So, okay, so that's working. Good. Okay, so now like begins the super tricky stuff of modifying the shader so that yeah, so that it matches what we had in the desktop version. Okay. So here we want to say added in text Pluto texture shader. Okay, so how are we going to do the next bit? Part of the next bit is easy, which is just literally replacing the image of Pluto. Like that's easy. Get rid of the New Horizons in the port. Instead, copy in both of these. Maybe the next step is just to draw both of these as like separate textures, and then before we start changing the actual shaders. Yeah, let's try this. Since we have a couple of things to juggle now. Okay, so I think for this part we can just copy in what we had in the. I should move the screen. We had in the sliding puzzle example. Why are there so many mains? What's the other main? Okay. We don't need the dwarf planet anymore. What we want is the sliding puzzle one. Okay, so we've got images. Here we want to wipe this stuff. Okay, so now we have two images, so we're gonna have to replace both of these. We'll just do the simple thing of duplicating both of them. Pluto with blue marble. And then Pluto with quote. And then we have to duplicate the textures for these. So where we had the Pluto texture, we now want, let's see, what did we call them in main? We just called them blue marble texture and quote texture. And did we define an alias for texture? Doesn't look like it. Does it matter that much? I don't think so. So gb.handle. Okay, and then we'll want to, well, we want to like set these at some stage, and here's where it kind of starts to get tricky. So so set up Pluto texture. This, yeah, all this is changing. Let's remind ourselves what we did in the desktop version. Okay, so up until this point in the desktop version, we set up like the background stuff, all of that's easy. And then the hard color texture stuff, where we have to set up 4 vertex attributes. Okay, and then we generate a texture for the blue marble. Okay, which is just like gen bind, set all the texture stuff, and then width, height, etc. And then we just repeat by the looks of it. Yeah, okay. So in our port, we want to replace this with blue marble and then repeat it for the quote. Maybe this could be factored. If we wanted to factor this, what would we need to do? We'd want to return. We want to return this thing. here we'd want to pass in the comp time stuff instead. You know, I think it's easier just to repeat it. We should keep in these, keep in some amount of the, some number of comments. We'll move this to the top. Okay, and then we repeat it. But now, so now we want to replace Pluto here with blue marble. Anything else? Maybe not. And then here, we want to change Pluto with quote. Okay. When we draw this, let's draw both. You kind of want to draw both textures. This is where like this is where things start to become a bit complicated. Let's just verify that both of them are getting drawn. Like we'll draw one on top of the other and then just like uncomment it. And then I think that would be enough confirmation that we don't then need to change the setting up of the textures. It's just about how we call them. So okay, so here. Are we still using the Pluto shader program? I guess that's something we need to change as well. What is it called in main? Did we not call it program? Oh, we just got a background shader and then color texture shader. Okay. So here we want to replace Pluto shader program with just Pluto shader with color texture shader. And then here, when we bind the texture here, this is where we instead want to bind blue marble texture. And I guess for the moment we want to keep this this Pluto texture location in, but since we are going to adjust the fragment shader, I guess we don't need to change that. We'll try compiling this. What now? Redeclaration error 165. Other declaration in 140. Oh, I see. So let's call this here is really the blue marble pixels. I quote pixels. Let's move all of this stuff up. Blue marble pixel bytes. Oh, this is the copy pasta errors going on. So let's see. Get everything in the vectors, expand them out into the bytes. Okay. Pluto QRI unknown. Right, this stuff we're going to have to repeat for each of those instances. So now we do replace Pluto with the blue marble. Replace Pluto with the quote. Then similar thing here. Oops, I should have. Well, redeclaration of VM width 436. Yeah. Right. This is VM for like blue marble width, blue marble height. So instead, we want to do VM with quote, and then. I feel like this really should be factored, but it's like refactoring it is just adding in complexity. Okay, a local constant shadows declaration of quote width. Where? Oh, we already. what did we do in main? Oh, we just called it queue height and queue width. Okay, another redeclaration. 439. Oh yeah, it's not just like a general pixel data object anymore. It's now like blue marble pixel data object. And then we'll have the Q pixel data object here as well. Okay, but that compiled. Let's see if it renders. It didn't. Index out of bounds. Oh no. That's not good. Why are we running into like size issues with the WASM now? We got this like last time. We tried to do something tricky. Indeed, it wasn't really tricky at all. This is no good. So let's say we turn some of these off. No, again, we're getting us out of bounds. What? Really? Ooh. Oh, yeah, what's going wrong here? We've changed a lot. Please refresh to debug. Well, I pressed refresh. No, we're not doing this. Surely there's like no internal size that we're failing. Maybe we were too ambitious trying to load two textures, like replace two textures at once. Why don't we just literally just like replace one with the image of the Earth and see what happens? Yeah, git checkout dot. Added in blue marble quote assets. Where's the New Horizons located? Well, that is located in assets as well. Okay. We'll probably delete that, but for the moment, blue marble. Okay, so just that change alone, will it still compile? Or does the size of this actually blow up the stack in some way? 13 build, sliding. Unable to open, file not found, huh? Oh. Okay. Oh no, was it like a freaking oh no, this is so weird. What? Okay, so what's going on? All we've done is just replaced one file with another and it's not working anymore. Okay, let's clear the temporary cache, relaunch this. Okay, this definitely seems to be occurring, and then so if we instead replace this with what? With Pluto New Horizons.qi. Build that instead. What? What? what's happening? Okay, curiously, like the blue marble.qi is like more than a kilobyte. Like it's like 1003, and so okay, if we replace this with the quote, do we also get an error? Okay, this is fine. So it truly is like the size of it is ruining it. That's kind of wild. um. Like yeah, like why? This shouldn't it shouldn't just fail because like the file is slightly larger like that. Like I'm guessing the limit is like a kilobyte, but this warrants investigation. Bizarre behavior. Is it like maximum like yeah, page size in WASM? Like this is so ridiculous. Like Chrome's like, we need 4 GB is a better limit. If you need 4 KB of memory, make a desktop application, not something on the web. Like, come on. But here we're like running into an issue on the kilobyte level, not on the gigabyte level. What to do? So this is clear. Well, so I'm pretty sure this is related to memory. Were it related to size, what else could be the culprit? I wonder if it has something to do with um, like the size, of the image, but I don't think it would. Yeah, okay. So say we made a really simple file that's like larger than 480. Like, again, I'm skeptical that this issue is to do with the fact that the canvas size is like 480 or something. So if we did like something new, and it's like 1,000 by 1,000, but something that will compress really simply into say we like make it totally this color blue, and that's all it is. And we add this to where is it? The port. Save as, export as. Blue.png. Whatever, export it all. Then if we magic key this from blue to blue.qri, so now it's like really large but still like as small as the quote almost. Let's say we now embed this far as blue. Oh, okay, now we actually get index out of bounds. Okay, so maybe it is something to do with the size. That's, okay, I was not expecting that. Okay, really? Really? Okay, huh? Oh, maybe this is like literally to do with the no, I was gonna say like to do with like the size of like if it's like if like the index or something is like okay, so maybe like within the WASM, like a fixed size has been determined for like the length of some like pointer or offset, and then yeah, literally if like the texture is too large, like the index I think we could actually debug this with like printf debugging. Okay, so let's just assume it's like basically in like the WASM, there's some field that's keeping track of like the position in the array of all of these whites, and like you basically get like an overflow of whatever that integer is. Okay, so say that was the issue. How could we find that if we just look at like the Pluto height and like the decompress thing. Okay, when we we're gonna have to issue. So it could be failing here. Let's say we did console, was it console log? Or just log? It is log. Log string decompressed debug. Okay, let's see, build that again, get that working. Okay, it failed before that, presumably. Attempting decompression. And I'm like paranoid this isn't working. Yeah. Oh, what? Are we not even getting to execution? Let's say okay, do we even reach main? Okay, we did get to program start. So yeah, where does this fail then? Like I don't know how to like run this through a debugger. So I feel like this is where I'm at. Okay, so maybe like when the stack is attempted to be set up for decompressed Pluto, it fails. But I don't see why that would happen since we're not assigning anything in here. Like what's the issue? Store offset is 12. I32. We're not doing any, like, this isn't destroying the memory and user space, right? Yeah. Okay, so I guess this 18321 is where it's saying it's failing. It's failing this, presumably. What else is happening in here? So okay, all of these are labeled like function like 45 to like 46, etc. Okay, and so does this mean anything? Parameter I32, I32, does this actually correspond to this? Not that I can see anything in there, no. So like, presumably this is like the main, or maybe it's like some setup, like it's like, call these 5 functions one after, like this is the first time I'm actually looking into any WebAssembly. I guess we're actually we're calling like 9 things here, but we're calling like debug several times, so maybe when we're calling debug, that's like actually 43 appears many times, so maybe 43 is log string. But I don't see it. Yeah, okay. It appears 3 times, so 43 must be seems to be this. Okay. So then if this is the theory, we'd expect to see another call in between the two of them, 4 calls in between those, and then some version of a call afterwards. So yeah, we see 42 in here, 4 calls in between them, and then 49 must be the animation loop. Okay. So where was this failing? This failed 1832 within 43. So 43 corresponds to, wow, but if it failed in 43, it's like failing in the, what? It's failing in it's failing in log string. What? That makes no sense. Like 6806, like, isn't it? Why isn't this going to line 6806? Like beforehand, this was this not taking us to the instruction beforehand that it failed on? Like why can't I look up 1606 here? Okay, I guess this is so silly. Can you show me the line numbers so I can look it up? I guess I have to guess with this bottom right corner. So silly. Okay. This is so silly. This is ridiculous. 680006. So it's failing here. Can I like save it? Okay. Not 6806, but close enough, I guess. Presumably. Okay, so then this is what? This is within function 56, which is what? Which is where? Oh no, 56 is like in between this somewhere. No results found. Why can't this find 56? This is so silly. 56 is here. Like what? Why is it like showing that stuff up? Yes, yeah. So what's calling 56? So 44 is calling it, and 44 calls 54, 55, 56. Okay. But if 43 is like the log one, then it's saying this is failing within a nick clock. Like what? This is so painful. Like yeah, like how do people do this? Like who do lots of WASM stuff? Yeah, like how to debug WASMs. So they're just like using scripting and then something. No. Okay, so if the claim is that, yeah, if the claim is just like the length of the array is like too large in some way, I mean, what could that be? Let's so let's just you know to make sure we're not like going completely nuts. When we build it with quote, it runs. Yeah. And so we're going to have to do some stuff with like the image sizes. So okay, so what even was the so if we do file pilot assets, what are the sizes of these things? So so the blue, which was failing, I guess the blue is also like 8 kilobytes. Okay, maybe that is a bit too large. Tell me, like, what are the dimensions? There's some way of finding out this info. Yeah, it was just like 1080 by yeah, 920 by 1080. Dude, so yeah, 920 times 1080. This is above the limit. We can like yeah, like what are some possible limits? So say we did have the 480 by the 480. The 480 by 480 was okay. So maybe like you can go up to 16, but you can't go above that. This is totally like ridiculous checking at the moment. If I don't, there's only like so much of the WASM stuff I want to like look into and chase. I think this is going down like a technical rabbit hole I don't want to go into, and also Andrew completely rewrote the WASM backend anyway in version 14. The reason I'm not using that is because I'm still waiting on Sig JavaScript bridge to be updated, and that update might fix it anyway. I'm kind of just feeling at this point the easiest solution is just reducing the quality of the earth texture, because who really cares about that anyway? It's kind of a small game, and then I think it will just work. And then exactly why it's failing because of some pointer size, it probably is due to like a bug. Like it's either due to like a bug with, like it's one of two things: a bug with Zig, in which case it may have been fixed already and it's in version 14, or it's some property of like the Firefox WASM specification. I'm not interested in looking at one and then like figuring out some like workaround with some like fancy memory mapping thing. Like I'm not doing that. So let's just simplify the size of these things. Okay, so sliding puzzle main. Where's the link to Wikimedia? Yeah, so let's just get like so weirdly it was like it was already like 480 by 480 before. Well, I think it was. So we know this one should work. Yeah. Alright, that seems like that. It seems like a really big version. So let's save this in. This is not the one I want to do. The port. Blue Marble 480 JPEG. Nope. Port. Come on. I'm so sick of PowerShell. Like any product where like the product name has like some verb that describes what it is, it's always terrible. Like if it's like vector graphics, if it's like vector graphics scalable format, it's like vectors are automatically scalable. It's terrible. If it's like PowerShell, it's like, oh, it's like this is powerful. It's like no, terrible. It's like it's such a universal rule. File pilot, it's like that's fine. That doesn't tell you any qualifiers about it. So we want to do magic K. We want to convert the Blue Marble 480 into Blue Marble 480.qi. How large are these things? Okay, so it is significantly smaller. So now we can do Blue Marble 480. Now build it, run it. Looks like it didn't load. What? So we're using the quote texture somewhere. Quote texture. Yeah. Is this the place we want to do it in? No. Where are we activating this? Oh wait, no, we're in the wrong file. Oops. Embarrassing. Okay. Blue Marble 480 QI. Zig. No, wait. Okay. Let's just get rid of this one. Zig build blah. launch it. Okay, it is loading, good. Yeah, but this is like another, like it's, and I think unless you do this, you don't like run into, you don't become aware that there's like problem with like the size of the files and like WASMs and like it's like okay, it's not as, I knew this was like fragile, but not like, now I can say it's like fragile with regards to like memory size. Okay. Let's just save this. It already took a lot of effort to get here. So what are we changing? In assets, we're deleting a bunch of stuff. All of this stuff can go. Maybe we should just like keep the blue one as an error, like just so we, if in the future we can debug it. Including gives sort of error test, and embedding gives like embedding error, or yeah, embedding gives error test in Zig 14. We may as well keep that in there. We want to add everything. Got blue marble rendering. There is an index like out of like what even is this? It's like the too high index error. It's like the index out of array. There is like an index out of array error when the dimensions, when seemingly the dimensions of the image are too large. Okay. Yeah, I was really optimistic about how much of this port would be completed today. Maybe it's going to take like another 2 streams to get this done. Anyway, let's at least get to the stage where we can render both like the quote and the texture at the same time without some weird error. So I guess to do that we just want to duplicate a bunch. We have to, we know what we need to do. We want to just duplicate this. Pluto here becomes blue marble. Pluto here becomes quote. And then the assets here is quote. Okay. And then in the decompress, let's just keep in some of these debugs. We'll keep in that one. keep this in. This one first. And then this one. So then we get both of these pixels, but we're not doing anything. Wow. Do all of that and then do it again for blue marble. Okay, let's see if this doesn't blow up the memory in some way, or push, like, make an index go too large. Maybe that happens. 13 build sliding puzzle 418. Doesn't know what these ones are. Understandable. Are we still referring to this stuff as the blue Pluto texture? Yeah. Okay, that decompile. Will it run? Index out of bounds yet again. Damn it. Why are we blowing up? Like, why is this happening? Why? How are we blowing up the memory in this way? This is not cool. Not cool. But and the weird thing is we got like a program start. It's just we didn't get anything past that. This is so fragile. Okay, what if we just imported the quote twice? The quote is really small. Okay, this seems to have worked. Gosh, like how, like what? I guess we kind of know the solution now. It's just yeah, we're making a new window. The solution is just to use like smaller and smaller versions of the texture until everything fits. So let's try like 240 by 240, which is kind of the size that it is in the game anyway. So this was 240, right? Blue marble 240, and then go into assets. Magic K, blue marble 240, blue marble. Yeah, 240.qri converted. Okay, and then, well, they have nothing other to do than just to to try compiling it, which is, of course it will compile, and then try running it. Okay, that worked. So, okay, I'd suspect, like, since we're like at this really like fragile memory part, if we actually replace this second quote here with the blue marble 240, this would fail it. It would be too big. So we can check it out. Okay, no, okay, it's small enough that it's okay. But the moment we replace this with the 480, then we get completely busted, right? Yeah. Index out of bounds. Everyone's favorite issue. But whereas Zig's type safety actually tells you where the errors are, this does not. Okay, so unless we actually did like release safe, I wonder if that would. Okay, let's say we did optimize equals release safe. I think it's worth giving at least this a go. Oh wait, it worked? Is the only thing we needed to do was like what? So like in debug mode this fails, but in release safe mode it doesn't. This would be totally ridiculous if this is true, but I suspect it is. Okay, so say we like made this blue.qoi, and we do like the release safe. File not found. Oh yeah, it's like bloody renamed it. Assets. Blue embedded error gives test in debug mode. Blue.qi. Okay. Compile it in release safe. No, we still get index out of bounds. So maybe it's like there's two different issues. There's like the size of the array is one, index out of bounds, and then like the memory size is a different one. So yeah, that still fails, but can we do 2 lots of the blue marble QRI in release safe mode? We can. Okay, but here, so then I guess here's the weird thing. If we, okay, will this work in release fast? Let's see. Okay, works in release fast. But the moment we make this debug, it fails. Oh my goodness. This is so ridiculous. Okay, I guess from now on we're just like making this in release fast. Yeah. Such a weird bug, but okay. Don't actually need to compromise on the size of the things anymore. It's not as if doing it in debug mode is like helping us anyway, since we can't even debug it. So, okay, it's release.fast from now on. What was the size of the original the original blue marble. I guess we deleted it. I think in either case we can go with the 480. I think the 480 is fine. Okay, so okay. So let's just put at the top. Yeah, I could say like note in Zig like 0.13.0 compiling the project with in .debug mode fails. A index out of bound, like a runtime index out of bounds error ensures this bizarrely does not occur when compiled in .release safe or .release fast. Okay. And then we can say by reducing the size of the QI files enough, the project can compile in .debug mode. Okay. Yeah. Okay. This has been such a mixed port. Okay, but now we know what to do. So. So yeah, so we can 480 version, the quote version, and yeah. So now I think we want to change some of the names. So there was this like Pluto texture. Now we want to change this to blue marble texture. But not this part, since this is in the shader that's going to change. Okay. And then we want to change this, so instead of blue marble, I can just say quote, and it should likewise work. Unidentified quote texture. Okay, blue marble texture. Pluto shader program is going to have to change as well. Quote texture. So this is where we want to duplicate this stuff. Okay. Blue marble pixel data object, blue marble height, etc. Let's just duplicate this. Set up quote texture. Oh, come on. Blue marble quote. Okay, and then here we want this to be quote, quote, q pixel data object, q height, q width. I think that's almost it. Uh-oh. Index out of bounds again. Why? Oh, yeah, why? Alright, what did we just do that failed this time? Okay, so now maybe it's another memory issue of alright. So maybe in release fast, it optimized out the decompressing of one of the things. But now we're actually like using both of them. It's failing. Let's just try using the smaller texture. So the 480. Let's replace this with the 240. Try again. Haha, great. Problem solved. You don't need to worry about memory issues when you just shrink everything down. Okay. This should also work, well, does this work in debug? Okay, kind of works in debug as well. Let's just like delete everything and check once again. Okay, it is. So then I can just replace the quote texture here with the blue texture and blue marble texture. Okay. Good. This is good. Okay. Yeah, like porting this example by just starting from nothing and working up was the correct approach. Very happy I abandoned the other approach early on. Like stuff like this, my goodness, totally unpredictable ahead of time. So now what? So now I think we now have both of the textures on the GPU, and so it should be possible to start you know what, we could even I'm pretty sure in debug mode all of this stuff, the textures are on the GPU. A way of guaranteeing that both are on there would be to every like second change up the texture. So what if we said constant current texture is equal to if the time seconds f32 what's like the zig intrinsic assuming it's been implemented in the WASM for like just looking at the floating point part. Or we can even just do float to int. So let's just say like time whole seconds. And let's just make this like a I32, and that we'll call this like float. Int from float. Time seconds. It's like so nice to be like back in like the Zig world instead of JavaScript world. And we can just say if time whole seconds. I want to just do like and 1. If it's odd, current texture is equal to if this condition is equal to 0, then like the blue marble texture, right? Blue marble texture else quote texture. And then here we want to bind the current texture. Okay. That compiled, let's run it. Fantastic. Both are on the GPU. So we are able to, this totally looks like, this is reminding me of Charlie XCX in some way. Anyway. So that's great. So since that's, let's stop that. Let's save this. Finally got both textures on the GPU without a crappy like what even was like index out of bound error, probably like memory like some hidden memory like memory limit. Okay. Okay, this is took us a while to get here, but they're both on the GPU. So now okay, so let's just remind ourselves why we're doing this again. So in the sliding puzzle, we want to put this. So yeah, we've got the two textures on the GPU now. So then we've also got the background shader working. So now it's a matter of converting over the admittedly complicated vertex and fragment shader for this, and then yeah, and then and then rendering. But even to do this, we're going to have to like copy over a lot of like the rectangle data and other stuff from the game. Oh, this. we better not like blow the size because of like the instruction case or something on the WASM. That would piss me off to no end. But now that's like a possibility. Okay, so yeah, where to begin? So let's check out the, go to main. Everything we need to, all the logic we need to port over. So a lot of rectangle stuff. Oh no, I'm just thinking, the way we're like drawing all of this is to like construct a bunch of triangles. Each of these triangles is like, each vertex is like a float, which is like 4 bytes, and so yet again there may be like an index out of bounds issue. But I suppose the savior is that we can actually hard code all of this stuff ahead of time. So there may be a way of getting around that bridge if we need to, if indeed we need to cross it. But like we have like a miniature saving point, right? Which is that like the next time we hit like the index overflow, we just upgrade debug to release field, and then after that we're screwed. We have the ability to push the envelope slightly. There's so much to import. So much. We're also gonna have to transition some of the buffer stuff to like the sub buffer. And then start drawing it with this. This is a lot of work. I think the update state we can, and the process input we can ignore right until the very end, I think. Yeah. This compute grid geometry, I think this is the next step. So yeah, a long function, long procedure. And this calls a lot of other stuff too. A lot of constants to add. And this is calling stuff that does buffer stuff. So okay. So we're calculating a bunch of rectangles, and then what are the commands? Draw color texture. Draw a bunch of those. If it's animating, this is like a it's just like it's just code that wasn't factored. From memory it was like tedious to factor, and it was just easy just to copy it again. Okay, this isn't as large as I thought it was. Let's try and get this in the game. Actually, maybe we first just like since we're now heading back into the fun of like OpenGL versus WebGL shaders, I just want to get like the fragment shader working, and maybe the best way to do this is to currently just hard code some values. So okay, we did something weird in like the render where we when we drew the quote, we like we called this okay, let's just get the quote rectangle on the screen. And I reckon at that stage we can kind of call it a day. Oh, it's nearly 6. Okay, I think it will be possible to do this. Okay, so in order to do this, we're going to have to copy all of this. Animation. Okay. So all of that stuff is background stuff. I think we want to insert it here. Okay. So binding the quote texture. Oh right. Okay. That's right. We have to convert it to the OpenGL way of doing things. Okay, so this is what we want, and then we need to rewrite this stuff to express it. So let's change this Pluto shader program to what it's actually called, which was like the vertex. It's like texture color. Color texture shader, that's right. Color texture shader. Okay, and then okay, we'll call this render the quote. So we're going to have to make a global for this buffer index. So why over here are we like binding the texture before calling the program to use it. Presumably this happened in main a bit earlier. Find that. Okay, use program background shader. When's the next instance of this? And then when we are calling the tiles, we use it again, and then not again. Okay. So yeah, call the color texture shader. So maybe we actually do this above since we will need it. To do render the tiles. But otherwise we then jump down to vertex buffer index equals 0. Yeah, and then we make the quote texture active. Which I guess has already been probably called earlier, but in this case we need this. Hang on, also we did like save all of this, right? So instead of current texture, this is just quote texture. Okay, and then so we've done that, and then let's just comment it out. And then we need to get the quote widths and height. None of this stuff is geo related, so we can just copy it verbatim, including everything in here. And then okay, and then we've got our like buffer subdata calls, and then a draw array call. Both of these we will need to translate. So this buffer subdata one will be gl context call buffer. Like let's just assume it's the same. I don't have patience for not if it isn't. That constant 0. What's this? scint buffer vertex index 80. Let's just copy that in. Yeah, we'll make it. We'll make it the same. Right, the vertex buffer here, we're going to have to do something different with since we need to spawn like the object. So then this is going to be vertex buffer object. This is a void, or it should be a void. Okay, and then finally the draw arrays command, and we've already done that. Draw the quote. But instead of 6, it's now vertex buffer index. Like, we know this is actually like a 4, but like what, like it's just a rectangle. Whatever the number is that makes it a rectangle, which can be worked out at any time. Okay. So then everything else can be commented like that. Now we'll need to, okay, so now we can try compiling this and we will get fails because we need to define, if we wanted a lot of things. Main. So we need to define the vertex buffer index. We also need to just define the vertex buffer and the rectangle. And the rectangle generating function. Okay, where to put this stuff? Okay, and then this color texture vertex, I'm like really worried that we're going to get another memory issue. Is just this. Oh well. Maybe we just copy both. So yeah, color texture vertex, then the buffer. Okay, so setting this to be like 500 is unnecessary at this stage, and again, I'm just afraid it's going to fail it. So, what if we're drawing like the rectangle? We only need 6 vertices, so we can even make this 10. Okay, then the vertex buffer index. That's the U size. Put those to the side. Okay. So again, when we're rendering this, ooh, what about like the space black? Is it going to? We're gonna have to define what that is as well. We've already defined the animation quote fraction above, I think. Oh no, wait, no, we need to define that too. Space black is, let's just copy in all the colors now. Where we're here, put it, wow, yeah, we'll put it here, wow, yeah. And then, space black, okay, animation, quote, fraction. Oh, we've already got this in the animation when we copied it in. Okay. Why didn't it show up before? Ridiculous. Okay. So, okay, so all of that is a thing, and then we need to copy in the function that is creating the vertex buffer data. So this draw this thing. Oh, this is a big function. This is big. Oh, there's so many other stuff in here that we're gonna have to copy in. Yeah. Now we can copy in the rest of the type aliases. Anything else? Okay, let's try just getting this to compile before we adjust the shader. Undeclared identified vertex buffer object 627. Right, because we want to create that. Oh, this is the one where we need to be really careful about how we, is this one where we need to be careful about how we get it? I think it's this. It's just ZJGB UV8 array view thing. So, let's see. Vertex buffer equals. Wait, where is this defined? Okay, it's here. Oh, it's gonna like. Oh no. This is like a pack struct, but I think we're already doing too much. I forgot this. Since this is like a pack struct, and we can't easily, well, we can't do like a pointer cast. We're gonna have to like rewrite it as like converting bytes and stuff. Yeah, I'm like rapidly losing interest in. There's already too much complexity floating around. Too many things can just like break at once, and you have no idea how they break. I feel like it's time to just like hard code in like even just like a single triangle that the vertex shader will draw, and then we just go from there. So we'll just go back in time. so we do want to do the current texture, then we're not doing this vertex buffer yet. Okay, instead we want to do we're going to just copy whatever's happening here. Actually, no. It's even this. Let's clear everything. This wipe everything. Okay. I completely forgot it was like the pack struct. That's so annoying. Yeah, let's just modify the fragment. We'll continue to do like the fragment shader, but just drawing the data we're drawing is not there's like an array with a bunch of integers. We're changing this. Yeah, this is what we're changing. Yeah, so compile Pluto shader is now compile. We'll keep the name. Like we'll adjust this as well. We might as well do it now. Compile. It's like we're not. Okay, fine. We're not. We can adjust the names later. Compiling the shader, everything's the same, but this thing, well, no, the Pluto array buffer is what we want to change. Yeah. So what actually is, what do we need to change this to? We have to change this to whatever this like draw, color, texture, rectangle function was outputting. Forwards. The gigantic pack struct, where is that? That's what we want. This is what we just want. So we want x, y, r, g, b, tx, ty, l. And then this stuff will need to be modified accordingly. So let's make everything like all of the color values gray to begin with. 5, 0.5, 0.5. We tried macros, but Emacs felt like it wanted to indent stuff. Stuck us up instead. This is like so annoying. Okay. All of that. Oh, and then we need to give like the lambda values. So what should all of these be? I think we just want them to be 0 to begin with. Okay. And now this has how many arguments? 8. So it's yeah, 6 rows of 8 of 32s. And then I kind of want to adjust the height of some of these. What if we, instead of drawing these across the entire screen, we just drew them on like the bottom half? Then if we make all of the positive ones here zeros, that should do the trick. But yeah, in either case, got that. And then this is kind of like the only thing we want to change. Yeah. Okay, so then we need to change the attributes. Triangle GPU data. This keyboard is driving up the wall. Let's do we have to change the attributes. That's right. And this is the one where there's a bajillion attributes we copy in. We might as well just copy them from main. Vertex attribute. Here, all of these things. So that's what we need to port. I reckon we can just do it in this order. And then or how are we modifying these? This is now GL context core vertex attrib pointer dot parentheses that thing for no, why did it do that? Oh, it's because of Emacs not, come on. We should just format the entire line. This is busted. There should be some rule that like if you're defining a macro, indenting doesn't happen. Okay. F3, it's ridiculous. GL context, core, vertex, attrib, pointer. That go to the end of the line. Back one, comma, void, end of the line, front. So, okay. Painful, but done. And then we can get rid of those. Okay, and now we have to pass in we have to go to like the link stage of this and pass in the argument. So I think currently it's like a pause. Yeah, we have to change all of this. all of this is changing. Okay, so now we do, this was like, yeah, doing this step, like in my head I'm like, oh yeah, swapping the fragment shaders is just like one step. I can do more than one at once. This is a very involved step. Okay, let's do another one. So, okay, in the shaders, we're now replacing the fragment color shaders with the actual things. Sliding puzzle, shaders. Okay, fragment color texture. Copy and replace. Vertex color shader. Copy and replace. Okay. Now we need to convert them. Let's start with the vertex color texture. So yeah, what are the things again? So we have to have version 100 instead of 300 core. But otherwise, okay, and all of these outs here are these not attributes? Oh no, some of these are like going to be varying. Oh no, all of these things are the attributes. Okay. Attribute. And then, yeah, the outs are varying. And we need to do like the precision thing, I think. Well, we didn't have to. We didn't actually have to do it in this part. Maybe we'll get away with it. The shading compiler will tell us if this is okay or not anyway. Does this make sense? Normalize square pods. I don't think we need to do this. Oh, and then there's like the two. That's going to be an issue. Okay, then on to the fragment color texture shader. And where's the background? Likewise, copy all of this into the top. Okay, all of these ins are now varyings. The out is now just GL frag color, and otherwise, oh, this line is going to fail hard. It's a 1 instead of a 1.0. Okay. Okay, so then those are the shaders hopefully converted. What else are we doing? Okay, is this it? Is this all we need to do? Compile, shader. So we set up. Oh no! We need to. Yeah. There's a reason why. Where we need to change the parameters here before the link stage. Yeah, all of this stuff needs to change. Okay. So let's check out like the vertex color texture shader. All of this stuff needs to be linked. So okay, so we have a pos in 0, a color in 1, a tech coord in 3, a lambda in 4. Okay, I think that honestly is it now. Zig build sliding puzzle. Let's just use the previous version. Undeclared identifier GL 408. Oh right. Oh, I don't think it's gonna know what false is. Yeah, we're gonna have to look that up. GL, good thing we have the URL here. GL dot false, or false. Where's the list of everything? 8B82, 8B8, okay. So somewhere here is false. No, why did it go all that way? But this is geo false, right? Unless oh, actually no. If it's a vertex attrib pointer, we pass something different in. We can just copy what we've done this before. We can just copy whatever's above. Oh, it's literally just false. Okay. Yeah. That's even easier. Pointer from int must have a known result type. 408. Wow. Okay, let's just copy what's above. Oh, it's no longer pointers anymore. Now it's so we've got the stride, which is 8. Yeah, it was so weird. Like in OpenGL, you had to you were like passing a pointer for like the offset, even though it was like an integer. It was so weird. Okay, so now it's actually just get rid of all of that. The consistency size of okay, that compiled and plays bets as to whether it's gonna render. I don't think it will. Oh wow, it didn't. Who would have thought? Okay, so oh right, texture. Okay, so the fragment, yeah, so the texture, the vertex shader was good. It's the fragment shader that's failed. Fragment color texture. So in particular, it's this like stupid uniform. Yeah, that's that problem. We can just copy what we did in the Zig, Web, GL, WASM examples, in the looping fractal, there was some weird changes we had to make. And what are we doing? The example to look at is in the dwarf planet. Okay, so here it is. Like, we want to use this line instead, and then and then oh, is that it? No, it's something to do with like the texture line down here as well. Yeah, I remember that. It's meant to be texture 2D instead. Pluto texture. Okay, and are we still is this still referred to as the Pluto texture in here? Yes. Okay. Let's try compiling that. Fine. Failed to link, leaving the following log. Alias. Why isn't this saying if the fragment shader linked? Do we have to change for like the 5th time? We have to add in that like the fragment shader compiled for like the 5th time. This is, I don't know how I seem to just have to like copy this in a bajillion times. It seems to always happen. Okay. Oh, we didn't even copy it into like the background shader. Okay. I don't know how I seem to just like copy it and then it like disappears. But yeah, presumably because it's saying it's failing to link, it did actually succeed, but I want to see it. Okay, it did compile, great. So now, yeah, we end up with this obscure attribute alias as something at location 1. Don't tell me this is because there's like I have to like assign different names to these. I suspect this is the case. Let's call this AA pos, AA color, AA lambda, and AA everything. The vertex color texture. Oh no, I'm gonna have to like replace all of these with all these stupid A's. AA pos. Okay. No, it's still failing. What? Port. Oh, right. It was a copy past error. Okay, let's remove all of these double A's. There better not be like a second error, which is having like, we should have to like add the A's to everything again. That would be so annoying. Okay. Okay, begun main loop. Okay, well, what? It said like shader failed to link. Link must have a compiled vertex shader attached. Okay, a pos undeclared identifier. Okay. Where is that? Okay. I'm like itching to finish this. Oh, okay, it's done. Great. Okay, nothing on display though, but the shaders did link. So now there's the issue of why is nothing being drawn on the screen. I think it's because of this like normalized stuff. Yeah, I think, yeah, didn't we actually just like get rid of all of this and we simply just said this is a pos? Okay, texture is being drawn, and but the texture is like gray. Right, which we did set. So I think we just need to change a single integer and that will be a texture instead. And then we can retire for the night. So let's see, animation frame. We're going to go swimming and I'll try and squeeze in 1 kilometer in 20 minutes. It will be a race. Oh, I know it's Friday, so it's short. I guess I'm going for a walk instead. This was when we hard coded these values. We set these last ones to be a 0, but I think in fact we want these to be a 1 instead. Okay. Okay. Done. Oh gosh. Ugh. Okay. Oh, and it's flipping as well. Okay. Cool. So yeah, so now this is great. This leaves us in a solid position to still just like curious is again, like we're not using an allocator, so like memory shouldn't blow up, but it's scary. Yeah, it's fine. It's fine. Okay. So yeah, let's save this and then exercise time. I get diff. So much changed. Ported ported fragment shaders. And drew well, actually, before you do this, I kind of want to just change the ones to like 0.5 instead. And then it's like, then it will be interpolated. Can I just, can I update this? No. Great. Interpolation is happening. We've got all the ingredients. All the ingredients are working to port this over. The game is now just a more fancy version of what's on the screen. ported fragment, right, ported vertex or texture, it is called the texture color shader, right? What are the why do we call it the vertex color shader? The color texture. Ported the texture color shader. The game is just a more tidy version, fancy, well, like, yeah, it's just a cleaned up of what's on the screen. Okay. Wow, this was a total nightmare, as somewhat predicted. But we have now got this rendering on the web, or at least in WASM. So, yeah, next time is going to be, hopefully, there's basically no more GL stuff we have to do. We'll just need to activate, like, we'll get this drawing in front of the background shaders that we already ported, and then we just need to add more draw cores, do the game logic, do input, and then we've ported our game. So thanks everyone who stopped by. See you later.